the whole basis of our industry, our product, our listeners. We sell it to advertisers. Of course, to get to the listener, we have to have transmitters. And I am really thrilled today to have Kyle Magrill with us. Kyle's been a good guy in this industry, done some really good things, and I like him. Well, okay, so much for that testimonial. Kyle is going to talk to us about CW broadcast. And you might say, well, CW, circuit works. But why is it now CW broadcast? Kyle, you want to fill us in a bit?
Back in 2019, I was approached by the former owner of PTech, which was not Peter Forth. It was another gentleman. And we had been doing some contract work for them, designing web servers and so forth to go inside the transmitters. And at NAB, he approached me and said, look, I want to get out of this. It wasn't what I thought it was going to be. And he had sort of bought it as an investment, and was not very happy with its performance up to that point. And I initially declined and said no. And then he said, well, if you don't want it, then I'm going to just auction off all the equipment and stuff on eBay. So if you're at all interested, think about it seriously. So I did. And I thought, it will be a challenge, but on the other hand, it is a product. I mean, people always need transmitters, and it is a product that has a future. And of course, PTech has a lot of admirers. It's an old brand. It's been around a long time. But at the same time, there are some known issues that have occurred with that product line. And so the reputation for both the product and the support was not very high. Larry, who was the previous owner, had at least brought in a couple of people to support the product who I thought were doing a pretty good job. But that left us with the issues of the actual product. And I didn't immediately change the name because I wanted to understand the dynamics of the product and, what are its strengths and what are its weaknesses. And the short story is what we found was that PTech had a pretty solid, their exciter was very solid. The low power transmitters up to about 1 kilowatt were pretty solid. And then they started to run into trouble with some of the medium and high powered stuff. And Peter, I think, might have had a tendency to be he was experimental in one aspect, but perhaps not experimental enough in other aspects. One of the biggest problems that PTech transmitters have occurs in the higher power transmitters. And the biggest issue is he took a very simple controller, which was very effective in the low power transmitters, and transitioned it to the bigger transmitters, and it doesn't make that transition well. And the reason is because in a low power transmitter, you normally have one RF amplifier, and whatever happens to that RF amplifier, it either produces RF or it doesn't. In a higher power transmitter, you're working with combiners and you're working with multiple pallets of RF amplifiers. And the Achilles heel of Peter's original design was, if something goes wrong with an amplifier, the transmitter tries to compensate. It doesn't recognize that there's been a failure. And so the result was that, if you had a transmitter that was supposed to be putting out 3 kilowatts and a pallet failed, naturally you're going to lose a certain percentage of your power. Maybe it's going to go down to 2.2 kilowatts or something like that. The transmitter will then immediately try and crank up the remaining surviving pallets to make that 3 kilowatts. Well, a whole lot of bad stuff happens when you do that kind of thing. first, those remaining pallets probably aren't really ever going to be able to produce that kind of power. And secondly, the reject loads in the combiner are going to be very unhappy. And so what happens in older PTEC transmitters is you run into these situations where an amplifier blows up, what would have been a very simple problem, lightning strikes, an amplifier dies. Then the transmitter over the next few hours self-destructs, really. And so it's really a bad, it becomes expensive to repair these. And so a lot of customers who had them simply abandoned them. And this is not something as a manufacturer we ever want to see. We want to design transmitters that will still be with us in 20 years. So we have a lot of experience at CircuitWorks in control systems, right? We've been building remote controls. A lot of you guys have used our remote controls. And, you know, really it goes back even to the days in the 1990s when we were just building, you know, touch tone controllers for, you know, putting yourself on the air, remotes and stuff. And so what we found was that, you know, if we rethought the control systems in the transmitter, we could take what was essentially a reasonably okay RF design and combine it with a pretty good exciter and a new control system. And we could make a transmitter that was reliable, robust, and when something does happen, it doesn't become a big event. So my mission for the past 2 years has been to design systems that prevent little things from becoming big things. And I think we've succeeded. So what we did here was we decided, you know, let's temperature monitor all the transistors. That's a given. It wasn't being done. Let's take a look at temperature balance. Let's take a look at the current that we're supplying to each pallet. Let's take a look at, you know, let's make sure that no pallets exceed the current. Of course, we've got fuses, which weren't in there originally. That was, an amazing thing is I've seen pallets that were completely burned up. And when you look at the way the circuit was designed, in fact, here, I happen to have, this is an original PTEC power distribution board, okay? And basically all it does is you plug your power supplies in there, removable power supplies. You've got a total of 125 amps running along this bus, okay? And if you short a pallet, that pallet consumes 125 amps, okay? The circuits are not going to last very long on that, and that's exactly what happens. They burn up. Okay, so here is a replacement power distribution board. Okay, so one of the first things that you'll notice is that it still has the bus, but there are not on this one because this is an early prototype that I have, but there are now fuses on each of the pallets. So if a pallet shorts and it draws 35 amps, that fuse is going to open and that's going to be the end of that problem. But we're also, down here, we have a microcontroller that's been added. Its job is to look at temperatures and currents. And it's constantly looking for overloads in terms of too much current being drawn, and it's also looking for imbalances. So if we have a situation where a pallet stops operating, that is going to cause an imbalance. The current's going to drop down to near zero, and that is going to trigger an alarm that's going to talk to the main controller, and the main controller is going to basically turn the power down on the transmitter. And then, of course, we're also looking at temperatures. We've got maximum temperature sets and so forth. And we're now supplying software with transmitters that allows the users to go in and configure all of those settings. Though we think we have them zeroed in pretty good. We don't really think you need to change much, but we do allow you to make those kinds of changes. So basically, we're at the point where we have what I think is a reasonably robust, still fairly economical transmitter. It doesn't, the cost to own it isn't super high. It's competitive with our foreign manufacturers, but of course, made in the USA, designed here, and supported in the USA. So, when you call, you're going to get a guy that speaks English. That'll be Glenn up in Spokane. And basically, that's the long and short of what we did. So I've put all this stuff down here. I've got a quick PowerPoint that I'm going to run for y'all. And if you're ready, I'll go ahead and do that.
Go ahead.
Okay. And let's find the screen and we share it. All right. So here we go. I'll just hit some of these same points that we've been talking before, and we'll go from there. P-TECH is basically now a dead brand. It no longer exists as far as we're concerned. We only bought the assets of the company anyway. We didn't actually buy the company, but we now own all of the designs and all of the equipment that was originally P-TECH. So now it's CW Broadcast from this time going forward. And we changed the name because we have been working very hard to make changes to the transmitter. And I just didn't think that really the transmitter designs reflected so much of what Peter had done anymore as they reflect what we're now doing and what we're going to continue to do in the future. So as we talked about, we've made a lot of design changes to the transmitters to improve the performance and reliability, and they're a lot better than they were in 2019 when we bought the company. So basically, if a problem is detected, the transmitter will do one of two things. It's either going to reduce its power to about, well, it has actually several different modes. If the problem is minor, it'll just reduce its power until the problem is resolved. If the problem is more major, then it will either go to an extremely reduced power, probably, I think 10% is what we set it for initially, or 15% power. And if the problem persists, it will then turn itself off. And, it'll make the user push a couple of buttons on the front panel before it'll produce RF again, but it won't lock you out permanently. Okay, so we also have brought back the option of buying the transmitters now as just amplifiers. We get a fairly high number of people that have asked, can we keep our exciter and just use your transmitter as an amplifier? Larry had, pardon me, Larry had stopped doing that. So we've brought that back. You can now buy these transmitters as just power amplifiers if you want to do that. All of the transmitters that we are producing now use LDMOS finals. They're pretty rugged, and they tend to be more efficient than standard CMOS parts. So in some cases, we're able to get efficiencies up around 80%. I've never actually got one that high, but I have hit 79% on a couple of them. And typically they run in the 70 to 75% range pretty steadily. So they're fairly efficient. So when we design them, we're using 1500 watt transistors. We're using the MRF 1K50s in the amplifiers. We typically don't run these transmitters at anywhere close to that kind of power per amplifier. We typically run them at about 700 or 800 watts per amplifier. So we're doing that because we just don't think that the transistors really are capable of producing 1500 watts day after day, year after year on a continuous duty cycle. Our tests have shown that if you run the transistors up that high, you're typically going to get 3 to 6 months out of them, and then they're going to blow up. So we run them at reduced power. They will produce more, but we don't let them do that typically. About 1,000 watts is about as much as we feel comfortable letting those transistors produce. And of course, we have a few built-in features: stereo generator, FSK for people. FSK is more applicable to folks that are using these for translators for automatic station, identification, but it does save you from having to do that yourself. On the bigger transmitters, they've got hot pluggable power supplies. Eventually, but not yet, I intend to go to clamped transistors in the finals, so that when there's that when you blow up a transistor, you'll be able to just pull the clamp and replace the transistors. But we haven't done that yet, but probably by next year or the year after, we'll have probably transitioned to that kind of a circuit. So all of these transmitters now are self-monitoring. They are auto-reacting. They don't need a computer or software running, but the software is supplied so that you can keep an eye on what's going on and see inside. The web servers in these transmitters will now also show you all of that internal data as well, but the software updates more rapidly. Okay. So one of the things that I really like about work that Peter did was he was an early adopter of direct digital synthesis, and he did a lot of work. I can literally go back and pull out exciters from 2012 to 2013 to 2014 to 2015 when he sold the company. And it's really interesting to see how those exciters changed over the years. The basic design, of course, is the same, but the cool thing that he did was the sophistication of the way he controlled the stuff in the exciters changed a lot over those times. And they are still as good sounding today as they were when he designed the first ones. We use the Analog Devices 9910 direct digital synthesis chips to do that, which are the chips that are the most well, it's really the only ones that you'd want to use. That you can make a transmitter that uses other chips, but you wouldn't want to use it in a commercial product. So it's been pretty cool. I've really enjoyed working with these and learning all about these chips, and they are great sounding. They are amazing. They are so much better than anything with a VCO that I've ever worked with. It's just amazing. So Peter was fond of doing a lot of changes, and many of the people that have bought PTEC transmitters over the year, we've seen one-offs many times. We don't do that. We make the same repeatable product over and over again. That way we have some idea. If something goes wrong, we have some idea about what the heck is happening to these things. One of the advantages to doing this is, just like with our remote controls and our other stuff, if there's an improvement that comes along, these are going to be field upgradable. So if we design a change to a transmitter, people down the road are going to be able to buy these changes and install them and basically upgrade their transmitters to whatever the current factory standard is. And so that is my intention from here going forward, which is not to say that we're never going to produce a new model of transmitter, but that the existing transmitters, including some of the older PTEC designs, are going to be upgradable going forward. And that way, people that have these transmitters that are still on the air or that have gone bad in the past will be able to take them and improve them in the future. So I think that that's going to lower people's maintenance costs. I'm sure it's going to lower people's maintenance costs because we're simply preventing a lot of damage from occurring that would have occurred before. So, you blow a transistor, it's going to cost you a few $100 instead of running you $6,000 to replace a whole deck full of transistors, amplifiers, and matching circuits. So, as I said before, we're made in the USA, we're designed in the USA, we've got support in the USA. You can contact me for support, and you can contact Glenn for support. The cost to buy into these is very reasonable. I think if you compare prices, you'll probably find that most of these are that our prices are going to be very similar, if not a little lower than a lot of the foreign competition. We are going to support the previous P-Tech products. We will continue to support them. We will continue to fix them. And if people want to upgrade them, they can do so. So most of the P-Tech Gamma series transmitters that have been made since 2013 can still be supported and upgraded to the current models. So there's Glenn. So see, contact Glenn if anybody has a transmitter that that needs to be upgraded. And that's basically it. Anybody got any questions?
Well, one thing
I have a question. Why did you decide to put the fuses on the back plane for the power supplies on that board instead of on the individual power amp boards? So you could just pull it out, change the fuse after you realize there's nothing wrong and plug it back in instead of having to go to that back plane to change it.
That's a reasonable question. The answer is we were redesigning the back plane. We were not redesigning the RF boards. And I considered putting inline fuses with fuse holders in them, but those inline fuse holders tend to go bad after a few years. And I thought that potentially was a bigger source of problems. When we redesign the pallets, I will move those fuses to the pallets.
Kyle, I think it's a great deal that you're taking care of former P-Tech customers and keeping them going straight ahead. When you talk about this service, you're talking about the last 10 years of P-Techs?
Approximately. I say approximately, we don't know exactly when Peter transitioned to these RF pallets. Because things were not very well documented. But approximately, we know we can go back at least 10 years, possibly a little more, maybe 12 years in some cases.
Okay. Now, how about your control systems? Obviously, you are making good use of your SciCon background. What happens here if there's a problem? Does the transmitter notify you by email or text?
So it depends. I mean, if the transmitter, by the way, let me see how let's see, I've got this. Did I unshare the screen?
I did.
You did it. Okay, very
go
good.
right back. Go.
No, we're good. We're good. It's okay. I don't need to. Yeah. So if the transmitter has one of the web servers in it, then of course it will notify you by email, assuming that you've hooked it up to the internet, which not every site out there has internet. But of course, it's also gonna, it's gonna blink the front panel LEDs in an alarming fashion, and it'll tell you that there's been an alarm. So if you physically, okay, so there's a few things that are going to happen. Actually, it's going to flash the front panel, and it's going to tell you that way that it's got a problem. So if you end up physically going out to the transmitter site, you're going to encounter that. You're going to have to push some buttons to dump those alarms. Secondly, that data comes out serially as well as through Ethernet. So if you hook up a terminal to the computer, you'll see the serial data coming out that tells you that there's an alarm, and it'll tell you what it is. So there's more than one way to know that there's been an alarm condition that has occurred.
CircuitWorks has some dial-up control devices, so you could actually, if you lost your internet, use something else you've got where you could just call into it, couldn't you?
You could, sure. I mean, sure, you could do that. I mean, if you have a Sign Systems or a Burke or anything that can dial up, or one of our remote controls too, absolutely you can. But I mean, in the future, pretty much our intention is to put a web server in every transmitter. So in probably 95% of the cases, there is some sort of internet that's available. And I expect that most people are just going to get a notification by text message or email. And, they'll know immediately what the problem is because it's going to specify right there in the message what has happened.
One of the features that Nortel has instituted in the past few years is phone home, where the transmitter actually calls the manufacturer and tells them what's wrong, even before the engineer knows. Are you considering something like that?
We have thought about that. I would say that if I made that it'd be easy to do. It's extremely easy to do. If we made that a feature, I would make it a disableable feature, because I don't know that everybody wants us in their business. And I think it's a good thing to be able to do, because, we potentially could get notifications of problems before they become serious, which would allow us to contact the owners of the transmitters and say, hey, look, this problem is about to occur. So I certainly would consider doing it, but I would only do that. I don't know if I'd enable it out of the box. Probably I would, but I would certainly make a big note of it in the instructions that you can disable this.
Or maybe set it to, instead of calling the factory, call the local engineer or whatever.
Right, which they can already do, basically. I mean, you have access to all the same parameters that we do. So, it just depends on where you want to set the sensitivity for those notifications.
If I remember correctly, you have still more features that you haven't spoken about yet, but that you plan to implement.
Well, let me think about that. So are we talking about like audio stuff?
I think that's one of them.
Okay. So, everybody that's building a transmitter these days, ever since the BW guys did this, everybody that's building a transmitter is putting an audio processor in front of the transmitter. And generally they're getting better, actually, to be fair. I've heard some built-in audio processors that were actually pretty good. We're going to offer that, maybe not as an internal feature, but as an external add-on that you can get with the transmitter. I'm working with Hans at Stereo Tool, and we're gonna be building basically an adapter for Stereo Tool that will allow you to use their audio processor, and it will be very, very, very affordable. But the advantage will be that it'll have composite out, and you can take it and use it on another transmitter if you want to as well.
BW, I know that to put composite in, you had to go inside and throw some jumpers because they all came with the processors, I recall.
That's correct.
But what that was so good for is they did it so cheaply, I guess, because they did it in mass quantities. I don't know. But a person could buy that box and hook an antenna to it and hook audio into it, and that was that.
Yeah, and it's a big selling point. Absolutely, I agree.
And a lot of religious groups, that put little translators everywhere. That was a big deal.
No, I used to recommend them. They were lightweight. They were lightweight and affordable. Now, the fact of the matter is, when you look at the cost of their transmitter versus, I'll just say any other brand, you would find that you were paying somewhere between $800 and $1,000 for that audio processor. So, and just as an example, if you bought an equivalent power Nikon, it was about $750 cheaper. So you were actually, they were not giving that audio processor away. They were charging for it, but it was pretty affordable. And so that's sort of the target range that we're looking at here too.
The other good thing about BW is the British speak pretty good English.
Yes, they do, and their customer service was actually pretty good. I called them about a transmitter that I was taking care of that had overheated, and it had the fans had gone bad, and the overheating had damaged the LCD. And the transmitter was out of warranty, and they airshipped me 2 new fans and an LCD at no charge. So,
I had a similar experience with them.
I had a very good experience with those guys. So it's unfortunate that they went away. Somebody popped in a little text question and asked if we thought about buying BW Broadcast. So the answer is, of course, I've thought about it. The problem is that there are 2 families involved in it. Roger and Scott's families are at loggerheads, and they basically are not. And there's a court order that suspends everything, and it's not looking like it's ever going to get, it will probably eventually get resolved. But the fact of the matter is, the industry has kind of moved on from BW. They weren't, since they're not active, the stuff that they have is becoming less and less relevant. And so I'm not sure that at this point I would. A year ago, it might have been a different situation. 2 years ago, but the audio processing. Now, the BW owns a whole line of audio processing, some of which is actually pretty competitive. So some of their higher end stuff might still be attractive. But to be fair, I have to tell you, I've been fooling around with Stereo Tool for about a year, running on Raspberry Pis, and it's pretty good sounding. I really can't. The BWs just can't hold a candle to it. So,
well, as you say, that it's a little bit down the road here, 20 years, in fact.
Yeah.
Kyle, can you talk first of all about what power range are you currently building? And I assume it's FM only.
It is FM only, although we have been approached numerous times about building AM transmitters, and I actually have a design. I'm working with an engineer that I can't really disclose on some audio processing stuff, separate from stuff that we put in transmitters, but he's a very interesting gentleman, and he has some ideas for doing low-cost AM transmitters that we're going to explore when we get done with our current projects. So there is a possibility. I'm kind of intrigued by it. I'd like to be able to produce an AM transmitter that was good sounding, but cost effective, and that people could afford to buy even as backups, because most of these AM radio stations either have no backups or they're extremely low power if they do have one. So I would really like to be able to do that. I think it would be. I think it's a needed thing in our industry that if you try to buy a transmitter, you're probably looking at 3 to 6 months of lead time before you can even get one today.
That's what I've heard. Yes. Or
Yeah. Or more. Yes.
So what power levels do you currently supply?
So power levels as low as 50 watts on up to right now 3 kilowatts. We have designs that are capable of doing more than 3 kilowatts, but I want to make sure that we have the recipe right before we re-release those. Eventually these will go up to 5 kilowatts, and then we'll probably get into doing some high level combining and go on up to 10 or 12 kilowatts. But right now, 3 kilowatts is where I'm artificially limiting these to 3 or 3.5 kilowatts.
Okay. Does anyone else have a question for Kyle? If you do, press your space bar or use alternate A to open your microphone and let us know how you feel about changing the name. Is that going to change your view of the product? Changing the design, will that change your view? Changing the guys doing the support.
Hey, Kyle, how's it going?
Good.
2 letters, HD.
Yeah, good question. Was that you that texted that in a minute ago?
No, I got
Somebody else asked me about it. So I have been repeatedly asked about HD. Obviously, it's something that we're going to have to transition into eventually. You bet. The designs that we're using right now are Class C designs. So to do HD, you have to go to a linear design. And that means a lot more complicated transmitter, and it means that the efficiency of those transmitters goes way down. So I'm sort of thinking that, I'm thinking that the analog transmitters are going to continue to be produced for a long time, indefinitely, probably. If we release an HD line, it will probably be a lower powered line that won't be, I'm thinking we'll probably produce an HD only transmitter at some point. But I don't know. This is all I'm just sort of putting it out on the table and, throwing ideas around. So don't hold me to it, because they may find that that's not a practical solution at all. And we may end up building, a hybrid HD. But yeah, we will eventually build one. It won't be this year, I promise. It's probably 2 years down the road. Nice microphone, by the way, Brian.
Oh, thank you. I kind of like it. Not quite a Neumann, but
Looks good.
Thanks, Kyle.
Sure.
How do you see the remote control as a standalone going away? That all the transmitters and codecs and such already being web receptive?
Short answer is no. But I do see a decreasing market for remote controls in the future. The reason I think it's no is because there are so many sites that need a unified control system. As manufacturers, of course, we're all putting remote controls inside the transmitters. So for individual transmitter control, yeah, remote control is not absolutely necessary unless you are at a site where you don't have internet, right? Because all these remote controls are internet based, right? That's easy to do, and we're no exception. We're doing that too. And I sometimes chuckle to myself, and I think the first control systems that we built were all dial-up DTMF based systems. And when we started building the Cycon 8 remote controls, that's what we intended to build. And so there was a lot of emphasis on the dial-up capability of it. The whole thing is programmable by DTMF, for goodness sakes. And then we added software, and then we added the web server. Now the majority of them are used over the internet, people blow the dust off the telephone parts once in a while to make sure they still work, but nobody ever uses it. So, but I sometimes chuckle because I think, here we are putting web-based remote controls in our transmitters, and, why aren't we putting dial-up in them? Well, the fact is that I just don't think there's that much demand for it. Although there are certainly cases where that could be used, but that's what we make the external remote controls for. So, if that's your thing, then, that's probably what you're going to have to do, I think.
Yeah.
I talked to Jeff about that at Nautel, and theirs comes where you don't need anything. You just pick up all the transmitter readings on the internet.
Yeah.
But you need 3 other things, maybe 4. You need room temperature, you need tower lights, you need intrusion, not a lot of stuff. And I said, well, why don't you make a card that goes in your transmitter that would give you 4 more inputs? And of course they said, yeah, we'll think about that, but they never do. And
so you want to hear my answer to that? On ours, we are putting provision for a couple of external status inputs. The reason that we don't do more is because remote controls are a nexus between different systems in a transmitter plant. And when you start allowing external connections to a remote control that's built into your transmitter, you're inviting differences of potential to occur. And I can do status inputs pretty safely because we optocouple them. But I can't really safely give you like external metering because I'm really concerned about blowing up the transmitter from the back end. I could kill the controller in the transmitter if I'm not careful. So the reason we don't do it is because of the isolation factor.
well, status is good enough. Status is good enough. All you need is a temperature switch for over 90, a door switch for the doors open, or switches.
I'll present another reason too, Kyle, and that is that if the transmitter does fail and go off, you'll be taking all your remote control down. You wouldn't be able to externally restart.
It depends on the failure, Barry. If you take out the power supply, then absolutely that's true. The remote controls are driven off of the power. So most of these power supplies have either have a 5-volt bus that you can get access to, or if it's primary, then we're turning the power off through some other means to the RF cards. So yes, if you kill the power supply, then you're absolutely right. You've lost your remote control. But in most cases, the transmitters are still going to have power available for the remote control. And the remote control has to operate when the transmitter's turned off, after all.
It does.
So, I mean, you've got to be able to turn the transmitter on. So that's one of the first things you have to consider when you're designing one is, how am I going to keep this so that the users are able to turn the transmitter on when it's turned off. And so they do that. But if you unplug the transmitter to send it back to the factory, or you've lost the power supply, then yes, you've also lost your remote control, which means you've also lost your tower light monitoring. And
if you ship it back to the factory, you've lost all your monitoring.
You sure have.
Guarantee you that.
You sure have. But
your remote's not too expensive.
That's true. And I was just going to say, we make little 2-channel and 4-channel internet-based remote controls that are just a few $100s exactly for that purpose. Or for people to hook onto their sign systems and, get the critical readings over the internet and still have their dial-up capabilities. So, I mean, but for $400 or $500, you can get pretty powerful remote controls that can do what you need to do.
All right. Floor is open. Anyone else have a question? Have a comment? Are you a PTEC user that will transition to CW broadcast?
We'll send you a sticker for your transmitter.
I was, but my P-Tech it was before 2007. It was the old P-Tech, and it was only a 500 watt. I used it as an amp for a backup, and it never broke. But it wasn't used continuously.
Right, analog meters on that? Yeah.
Yes.
Yeah, I know the transmitter. I actually have one.
Yeah, the black front, and it had, you turn the power on and you could push a switch and you could just watch it go up on the meter.
Yep. Its design is, well, it's actually a fairly robust design. He used MRF 151s in those or equivalent. There were a number of European equivalent transistors. And there's a little horseshoe shaped combiner, which is made out of a different PCB material. And then he basically built two, so that gave you 300 watts. And then he built two of those in the transmitter and combined those to get you the 500 watts. And they are fairly robust, actually.
It never broke. And like I said, it was an emergency backup, and I had a little P-Tech P-Tech in front of it for an exciter, and it just was always there.
I know of one of those that is on the air right now with an LPFM. And it has been on the air continuously for years. The only thing that ever went wrong with it was after about 8 or 9 years, the power supply died. But those are just 48 volt power supplies. You can buy them yourself, or you can buy them through PTEC. And that's the only thing that ever happened to it.
On your 50 watt transmitter, Kyle, how far can you dial that down?
You can take it down to 0.
Oh, really?
Yeah.
Yeah, because I just saw a construction permit go through, or actually a license to cover for 500 milliwatts.
What?
Yes. A half watt ERP.
I don't think the FCC will authorize less than I was told the FCC would not authorize less than a watt.
Well, maybe if you're iHeart, you get special treatment from the FCC.
I don't know.
Somebody bribed somebody or hired to get a milliwatt.
Yeah, for a half watt, why bother? I mean,
well, they always say the first watt. Sorry, go ahead. I talked over somebody. I was going to say, they always say the first watt is the most important one. I'm not sure about the first half a watt. Damn.
I was asking because I've got a customer that only needs 4 watts. So.
Yeah. We can do 4 watts.
Okay, cool.
Yeah.
Thank you.
Sure. Seems like overkill putting a 50 watt transmitter on a 4 watt permit, doesn't it? Well, to be perfectly honest with you, Brian, the exciters, we set the exciters up when we're tuning them at the factory to put out 4 watts. So what he really needs is an exciter feeding into a low pass filter, and he'd have it. You might talk to me about that later. I think Glenn could probably do that for you.
Okay, yeah. I mean, okay, but it's a 4 watt ERP. So what's our line loss? What's our filter loss going to be?
Well, the exciters are actually capable of doing about 10 watts. We set them up for 4.
Okay.
So, does he have an antenna with gain? What's the situation?
Single bay ERI 100 series.
Okay, so it's a ring stub.
It's a rototiller.
It's a rototiller. It's a lightweight rototiller.
Yeah.
Yeah.
Okay.
Best way to phrase it.
Yeah, he's got a gain of about 0.49.
It looks like a lightweight Jam Pro.
Yes. Yeah. Okay. So he's gonna need more than 4. And how long's the feed line run?
I'm not exactly sure.
And what's it made out of? Is he putting up, half inch, or putting up some sort of flex, or what's he doing?
Oh, with my luck, it'll be 300 ohm.
Yeah.
Yeah.
Okay.
RG59.
I've put up RG58 before.
Well, I didn't want it to be that accurate.
Kyle, we have a comment here in
92
the
ohm
chat
cable
box.
company cable.
Yeah.
We have a comment here in the chat box about replacing a brand N transmitter that failed 4 times before being returned, but a PTAC that has worked flawlessly since. So Peter's designs were not in of themselves bad until, as you say, you got up to the higher powers.
Yeah, the problem with Peter's designs is they don't scale well. And that stems back to a control system that's too simple.
And he had another problem, which was the same Bernie Wise did. And you said that they were all knockoffs, one at a time. So the schematics and the manuals rarely match the product.
Yes. And believe it or not, even we don't have all of the schematics and board layouts for all of Peter's designs. There's a bunch of stuff in there that we just don't have. Well, I have Gerber files for boards that I don't have schematics for.
Mm-hmm. Yeah.
So
Bernie lost a lot more than that.
we had to go back and recreate schematics for a lot of that stuff.
Really appreciate a lot. And as you discuss this, is that everybody has had a transmitter and they say, I wish it was this. I wish the tubes weren't sitting there horizontally, not vertically, or I wish that the control circuit did this, or the interlock, or whatever. But you're actually doing it. You're taking a transmitter design and you're looking at all the things that you think should be in there and you're adding them one at a time.
Yes.
And actually doing it.
So if somebody wanted to tell you a feature that they would like to see, you're open to discussing it.
Yes. Products. Okay. So, circuit works. Okay. So 25, 30 years ago, I used to be an active broadcast engineer. And, back in the 80s and stuff, I had a pretty good feel for what the industry needed. But, after having been in broadcast manufacturing for so many decades, you sort of get out of touch with what the industry wants. And so I've always recognized that we have to be driven by customer request, because we don't have a way to stay current with the current needs unless we're either out in the field doing this stuff actively, which sometimes I get to do, but not very often. Last year, I spent several weeks down in the Caribbean building out some stations and seeing some new equipment that I hadn't seen before. But for the most part, I'm trapped here behind a desk, and I hear about the problems or the desires and the needs when people call up and say, it'd be really great if you could do this or that. And I go, okay, let's see if we can do that. So yeah, we're customer driven. We have to be.
I think that's the right way to go at it. And there are other transmitter manufacturers that are looking there. But it's clear that some of them are driven by the vision of the owner. Some of them are driven by the market. And then some of them, you talk to them and, yep, something shows up later, or in some cases, the software takes a few more years.
Well, we're occasionally guilty of that too. I will say this. I don't think any... I used to say that, there was really no such thing as a bad transmitter. You get a guy that spends $60,000 a name brand transmitter, and he puts it in a nice building with, a recirculating air conditioning system, and, keeps it well maintained, and it lasts for years. And then you get another guy across town, and he buys an inexpensive transmitter and puts it in a tin shed with and if it's lucky, it has some exhaust fan that blows out when the temperature gets above 100 degrees. And, it blows up every year. And the guy that has the cheap transmitter in the tin shed goes, that darn transmitter of mine, it's just garbage. And, that's not necessarily the case. I have since learned that there actually are bad transmitters. But I don't think anybody starts out to design one that way. I think that most people try real hard to design a good product, and it doesn't always work, but I think at least their intentions are usually good.
I guess we could have a contest here of the worst transmitter ever designed.
I may have worked with a few of them.
Yeah, I think some of us have.
So, but we're interested in obviously designing a good product, and we may not hit the mark every time, but at least, if we find out that we have some problems, we're at least going to go back and try to fix whatever it is that we did wrong, and hopefully make the product better as time goes on. I know a lot of people have our remote controls, right? We started manufacturing those remote controls in 2005, and you can still upgrade those to the current model. So over the years, we have learned, we have modified, we have adapted, we have built on, but I feel pretty strongly about not leaving people behind. So if we build a product, it's my intention that if we find that there's a flaw or an improvement if there's a flaw we can correct or an improvement that we can make, that we would make those available to people in the future as some sort of a retrofit.
Worst transmitter, FM. And since they're dead and gone, I can say it. I didn't want to drop any names, but it had to be the RCA. And they're out there still, but they're just used for other things like landfills, and stuff.
No, Jerry Olson's got the right answer, actually. Before everybody has to disappear, some of them do have some other things to get to. And I'm not chasing you away by any stretch of the imagination. We want to let everybody know that your website is still circuitworks.com.
Yes. Or you can type in cwbroadcast.com. That will take you to that same page.
Okay. So we go to cwbroadcast.com.
Yes, sir.
And there it is.
Yep.
It's beautiful, and it's made in America.
And there's a phone number to get Glenn's attention. And if they want to get you, are you in here too?
I'm not, but you can always reach me at circuitworks.com. The Kyle at circuitworks.com reaches me by email, and our phone number is on the CircuitWorks page. And I'm happy to talk. Glenn knows more about the transmitters than well, that's not technically true because of the changes, but Glenn knows as much about the RF as anybody does. And so, yeah,
you're going to have to fix that. Your number isn't there.
I sort of did that on purpose.
Oh,
but if you go to circuitworks.com, our number's there.
That's where I am.
No, you're on cwbroadcast.com.
No, sir.
Yes. There you go.
Oh, all right.
And look on the left, you'll see it there. Go up. There you go. I got to take our fax number off. We disconnected our fax about 5 years ago. I hadn't gotten a fax in 15 years, except for ads.
Was that a solid state fax machine?
Yes, the vacuum tubes wore out.
Can you imagine that medical industry still runs on faxes?
I know, and they say it's because of HIPAA. And I have, and before we stopped using our fax machine, I used to regularly get people's medical faxes. I can't tell you how many. Apparently, our number was just 1 or 2 numbers off from some doctor's office, and I used to get misdialed faxes all the time.
We needed fax machines back in the 2000s because if you had a blue box or something, it only worked good on a fax line.
Yeah. Well, you needed a real dial-up line for a blue box to work on. If you had a VoIP line, they won't work.
No, I meant an actual dial-up fax line because that was always the best landline you could get, and it didn't switch to anything else. It went straight to that fax machine.
Yep. Yep.
All right. Well, listen, I'm sorry that you couldn't get Glenn to come along and talk with us for a little bit, and folks to get to know him. Maybe we could do that again later in the year and
Sure.
drag him in here and talk a bit. But sure appreciate your taking the time to tell us about CW Broadcast and what you're doing.
Sure.
What's your biggest transmitter? I know you probably said this, but what's the biggest one you've got? Power.
Right now, 3.5 kilowatts. We actually are capable of building them higher, but I'm not comfortable with them yet. So I'm saying 3.5 kilowatts right now.
Good. We'll see what the future brings. And to go back to your earlier comment, and I know that you're speaking from the standpoint of an operator, streaming is important.
Yes.
But streaming clean audio is important.
Yes.
Not just throwing your program audio on a stream.
So the audio yes, and we're working with somebody on a product for that actually, but there are other products already on the market for doing those kinds of things.
Mm-hmm.
The streaming audio should sound, I think, as close to your broadcast stream, as close to your broadcast signal. Well, assuming your broadcast signal is good.
That's where the issue is of compression and limiting.
Yes.
You got about a 10-15 dB range in a car before it becomes inaudible, and you don't want to be quite that compressed on a stream.
But then a lot of people are listening to streams in their cars. So how do you account for that?
Very good point.
My daughter does it. My daughter's 18, right? She turns on the radio and listens to it. But then, sometimes she Bluetooths her. So, we talk about audio quality. I'm mesmerized by this because the audio that comes out of her radio when she's listening to the radio station in town is so much better than the compressed audio stream